Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the May-June 2023 Pure Mathematics paper 1-1 from Cambridge 9709. This question here is about a line with the equation y equals kx minus k, where k is a positive constant. So this is a straight line, which is a tangent to the curve with the equation y equals minus 1 over 2x. Find in either order the value of k and the coordinates to the point where the tangent meets the curve. Right, so we have to take care of a few things here. First of all, we're told that k is a positive constant. That will come into handy for us when we find the value or values of k we might find. And we have to be clear that we've got to do two things here. We've got to find the value of k and the coordinates of the point where the tangent meets the curve. So there's two things to find. A lot of people just read half a question and they find that and they forget about the rest of it because they didn't read the question properly. So it's always best in the beginning to figure out exactly what you have to do. Now, a curve and a line, okay. Well, a line is a tangent to the curve when the following happens. Say this is the curve, and let's say this is a line. I'm not drawing an accurate diagram. I'm just giving an idea of the situation. So this would be the tangent to the curve, okay? And the tangent to a curve only touches in one place. Okay, there's only one place in which the tangent touches the curve. It just touches the curve, it doesn't cut through it, okay? So basically, this is the line, this is the curve. Now, how do we find the coordinates of the points where a line and a curve intersect? Okay, we find that by solving the equation of the line and the curve simultaneously. So I have y equals kx minus k, the equation of the line, and y equals minus 1 over 2x, the equation of the curve. To find where they intersect, I solve this pair of equations simultaneously. Okay, now a lot of people will say, oh, equate them, which in this case works fine. But just for a more general understanding of exactly what to do, what you actually are doing is you are replacing the y in this equation by the kx minus k in this equation. You are substituting one of the equations into the other, and that will tell you where they intersect. So I'm replacing this y with kx minus k. So I'm going to have kx minus k is equal to negative 1 over 2x. Now I'm going to solve this equation. To solve it, let's get rid of the fraction first. Let's multiply both sides of this equation by the denominator 2x. In which case I'll have 2x times kx, which is 2 times kx squared, 2 times kx squared, minus 2x times minus k. So 2x times minus k is minus 2kx equals, and when I multiply 2x by minus 1 over 2x, I'm left with minus 1. Now, to solve this equation, we would like to write it in terms of, like, make it say equals 0. So 2kx squared minus 2kx plus 1 equals 0. Now, I know that this equation, in the situation that we know, has to have one solution. It has to be like this. There are three possibilities. Either the line cuts the curve in two places, in which case this will have two solutions. Or the line and the curve never intersect, in which case there will be no solutions. Or our case, the line and the curve, the line is a tangent to the curve, it just touches at one place, and that's the case that we want to look at, and that's where this equation will have just one solution. It's called a repeated root. Now, what is it, the thing that determines whether a quadratic equation like this has one solution or two solutions or no solutions? Well, if we look at the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is the part of the quadratic formula which helps us to discriminate between how many solutions there's going to be. Because if this is positive, you'll have minus b plus or minus something over 2a. So you have two different answers. Minus b plus something, that's one answer over 2a, and minus b minus something, that's another answer over 2a. All right? So you have two answers if this is positive. So when the discriminant is given a symbol like this sometimes they use this like a triangle. So the discriminant is b squared minus 4ac. If the discriminant is greater than 0, if it's positive, then you'll have two solutions. If the discriminant is less than 0, then you have minus b plus or minus the square root of a negative number, which will give you something that's undefined. So this will be no solutions. No real solutions. You can say no real solutions. But if the discriminant is equal to 0, you'll have minus b plus or minus the square root of 0, which is going to be 0. So you'll just end up with minus b over 2a, which is just one solution. You can say one solution. Sometimes it's called a repeated root. Okay? And that is the case that we are considering here. When the tangent to the curve, there's only one solution to that. Okay, one repeated root. So we can say as y equals kx minus k is a tangent, therefore we know the discriminant is equal to 0. So we can say b squared minus 4ac equals 0. Now in our case, the a is a coefficient of x squared. So the a is a coefficient of x squared, which is 2k. So a is 2k. The b is the coefficient of x, which is minus 2k. And the c is the constant, which is 1. So you've got b squared minus 4ac equals 0. So minus 2k squared minus 4 times 2k times 1 equals 0. So 4k squared minus 8k equals 0. Divide by 4 to get rid of the common factor. K squared minus 2k equals 0. So if we factorize this, we have k times k minus 2 equals 0. So either k equals 0 or k minus 2 equals 0, in which case k equals 2. Now we know that k is a positive constant, so k must be equal to 2. Okay, as we highlighted before, k is a positive constant, so that means k can't be 0, it must be 2. So k equals 2, so that's the answer to the first part of the question. Then it says the coordinates of the point where the tangent meets the curve. So basically, this equation that we formed here, is the equation that tells us where the line and the curve intersect. And we know that when k equals 2, this will only have one solution. So if I replace the k in this equation with 2, that equation will give me the place where the tangent meets the curve. So I'm going to replace the k with 2. So I have 2 times, so I've got 2kx squared minus 2kx plus 1. Was it plus 1 equals 0? Yeah, plus 1 equals 0. So we know that k equals 2, so that's going to be 2 times 2, which is 4x squared, minus 2 times 2, which is 4x, plus 1 equals 0. What you'll notice in all of these type of questions, if there's one solution, if there's a repeated root, this will be a perfect square. I'll give you the same answer twice. And we can see 4x squared is a perfect square. The square root of 4x squared is 2x. And 1 is a perfect square. Because there's a minus here, it's going to be a minus 1 there. And that's going to be squared. If we expand that, we're going to get 4x squared, multiply them, double it, minus 4x plus 1. So we can therefore say that 2x minus 1 equals 0. Therefore, x equals a half. So that's the x coordinate of the point where they intersect. They want the coordinate, so they need the y coordinate as well. We also knew that y equals kx minus k, kx minus k. That was the equation of the straight line. Y equals kx minus k, right? And we know k is equal to 2. So we know that if y is equal to 2x minus 2 and x equals a half, we can find the y value. When x equals a half, y equals 2 times, y equals 2 times a half minus 2, which is going to be 2 times a half, which is 1. 1 minus 2 is minus 1. Okay, so we end up with the coordinates of the point are a half and minus 1. And that is the second part of the answer. K equals 2 and point where they meet a half minus 1. That concludes this question from the June 2023 May paper 1, variant 1 for the pure maths. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of this, I guess, is quadratics, can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and the link here will take you to a video which explains how to use my channel efficiently. Thank you for watching, and see you soon.